This will be an overview of Chapter 2, the chemical basis of life, that will, a lot of these concepts will be on your next exam. Well, the chapter begins with matter. You probably have heard, I don't know if you've taken biology in high school, matter is anything that has weight and occupies space. Matter is found in both living and non-living organisms. It can exist as a solid, a liquid, or a gas. The next one, of course, is an element. Elements cannot be broken down into another substance. There are 92 naturally occurring elements in nature. The most abundant elements, which there's a figure 2.1 in your textbook on page 22, is showing that the most common elements in us, or the human body, would be oxygen, which predominates, is the dominant element, followed by carbon, hydrogen, nitrogen, and of course calcium and phosphorus. The others are considered trace elements. An element, of course, has two or more atoms attached to it. If you look on page 23 of your textbook, figure 2.3, they're showing you the periodic table of elements, but of course all 92 of the elements are not there. What is an atom? Okay, an atom is called the atomic theory, has subunits or subatomic elements, protons, neutrons, and electrons. Electrons have a negative charge, and they're found outside of your nucleus. Protons have a positive charge, and neutrons have a neutral charge. If you look at figure 2.2 on page 23, you can see inside of your nucleus, you have your protons, which have the positive charge, which are red, and you have your neutrons, which have has no charge, which are the purple figures that you see. And outside or circling or the protons and neutrons, you have a negative sign, which of course are your electrons. This is in your textbook, figure 2.2, which I just went over for you. There is an atomic number, and as stated before, all atoms of an element have the same number of protons. So, for example, if you look in your periodic table of elements, figure this table here, if you look, hydrogen has, if you say all atoms of an element have the same number of protons, hydrogen is considered an element. If you look at the number at the top, that's a proton. If you look at carbon, which of course the element for carbon is C, the number at the top is the atomic number, which shows you the number of protons that carbon has, which is 6. So, elements' chemical and physical characteristics recur in a predictable manner. Atoms are arranged in periods, rows, and groups / columns, which is what you see here. Now, according to the arrangement of electrons, I'm not going to go over this, but if you want to know more, let me just say this. Electrons, as we know, are orbiting the nucleus, which means they're outside of your nucleus. They're constantly moving, but they occupy what you call shells, and on each shell you can only have a certain number of electrons. For example, the first shell, 2 electrons can only be put on that particular shell. The second one, or the additional shell, in this case it's going to be the second shell, can have up to 8 electrons. Okay, now the octet rule simply states that when those outermost shell are complete or full, or has octet means 8, when there's 8 electrons in that outer shell, of course, is considered the octet rule. That means that that electron is considered a valence electron. Okay, so it says the outermost shell is your valence shell. If an atom has more than 2 shells, the outer shell is most stable with 8 electrons. Atoms can give up, accept, or share electrons. That brings us to the bonds that we're going to talk about. Covalent bonds is going to be the sharing of electrons. Ionic bonds, that's when you're going to have an ion that can actually give up an electron, or you're going to have an ion that's going to accept an electron. This is your octet rule here. Now, if you look at carbon, we're going to just look at the first one and the last one. Carbon has 6 electrons, which of course is your number of protons as well. The first shell or the inner shell, there's only 2. Remember, you can only have 2 on your first shell. The second shell, you have 4. Okay, so that's considered a valence shell, but it can hold up to 8, which means this particular carbon is unstable. If we go over and look at nitrogen, let's look at nitrogen, okay? Nitrogen has 7 electrons. The first shell you have 2, and of course the second shell you have 5, giving you a total of 2 plus 5, which would be your 7 electrons. Molecule. Okay, a molecule is a group of atoms bonded together. You do need to understand the types of chemical bonds that we are about to talk about. You also need, in order to understand the bonds, you're going to have to understand the difference between a molecule and a compound. Okay, so a molecule, when you have 2 or more atoms, I say bonded together. Okay, let's look at this for example. Oxygen, O2. These numbers that you see across here are considered atoms, okay? So oxygen is a molecule with 2 atoms. This is water, H2O. Hydrogen has 2 atoms. When you don't see a number behind it, of course, oxygen, that means it has 1. C6H12O6, which is the formula for sugar or glucose. You got 6 atoms for carbon, 12 atoms of hydrogen, and 6 atoms of oxygen here. Now, let's look at a compound. When you have molecules containing atoms of more than 1 element, okay, I like to use the definition 2 or more elements will make up a compound. So, if we look here, hydrogen is an element, oxygen is an element. So, water is considered compound. It's also considered a molecule. Why is it considered a molecule? Because it has, what, 2 or more hydrogen atoms. Also, if you look here, you saw the same formula for a molecule. So why is it considered a compound? You have an element. The following elements are carbon, hydrogen, and oxygen. You have 3 elements here. Compared to the molecule, you got 6 atoms of carbon, 12 atoms of hydrogen, 6 atoms of what? Oxygen. Okay. There are 2 types of bond. So ionic bond is when you have an attraction between opposite charges, your positive and negative. And of course you have your covalent bonds, which is the sharing of electrons to actually complete or fill that outer shell to make the molecule more stable. So, ionic bonding. Okay. First, let's talk about an ion. An atom that has an electrical charge is called an ion. If you look here, ions are charged atoms. Okay, so when will an ionic bond occur? It's going to occur between 2 atoms that have what? Opposite charges, because we know that opposites attract. One is going to have a positive charge, the other one is going to have a negative charge, which is called an ion. So we're going to take sodium and chlorine, for example. Okay, one of them is going to accept an electron. One of them is going to give up or donate an electron. Okay, so I need you to follow me carefully this slide right here. All right. Sodium. Okay, how many electrons does it have? 2 in the first shell, 3, 4, 5, 6, 8 on the, not 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 8 on the second shell, and you have 1 on the third shell. So this one has 11 electrons. I'm going to go back here. Okay, but it doesn't say that. Sodium has 1 more proton than electrons. We're going to talk about that a little bit later. So you have this one extra electron here on the third shell. Now let's look at chlorine, okay? First shell, 2. Second one, 8, which gives you a total of 10. And on that third shell, or the outermost shell, is going to have 7, okay? Now, it's so much easier for chlorine to accept this 1 electron than for sodium to try and pull 7 electrons from this outer shell of chlorine here. So this is what's going to happen. As you can see, sodium only has 2 shells now because it lost a third shell, giving up that electron. Now, chlorine, which had 7 shells, 7 electrons on your third shell, accepted this electron from sodium, now has 8. Okay, so sodium gave up or donated the electron to whom? Chlorine or chloride, which accepted the electron from sodium. So when it comes to charges here, which is really not, I don't know, you guys may decide to change your major to biology, then you'll take biology 103 and I'll get a little bit more detail with you when it comes to sodium. Now has this positive charge. Why? Because it has more protons now than electrons, which means it picks up this positive charge. Chlorine now has more electrons than protons, which means it's going to pick up a negative charge. Okay, so now let's talk about a covalent bond here. All right, so when you have a covalent bond, so if you go back, the type of bond that's going to form between these two, let's find it in your textbook. Go to page 26, figure 2.7. The bond that's going to form between these two guys is called an ionic bond. Sodium chloride will be the end result, which equates to, also known as table salt, which is what you see, figure 2.7, formation of sodium chloride. Scientific name for table salt is sodium chloride. So an ionic bond is going to form there. Now we have, we're going to look at a covalent bond. Covalent bond is when 2 atoms share electrons. 2 hydrogen atoms can share electrons to fill their outer shell. Orbitals are going to what? Overlap. So this picture here, page 27, you see in your textbook where they're actually showing you how atoms are actually overlapping. Because hydrogen has only 1 electron on its first shell, it only has 1. It needs 2. Remember, we have to have 2 electrons on that first shell. So what's going to happen is it has to acquire another electron from another hydrogen atom, and the 2 are going to overlap because they're sharing both of these electrons. Now they're stable. They're not going to react with another atom. So here, hydrogen gas. This little jagged line that you see here is called a single covalent bond. Why is it a single bond? Because hydrogen is sharing 1 pair of electrons. And of course, you can have a double covalent bond as well when you only have 6, which is oxygen. Oxygen has 4. If you go back to your table, oxygen has a total of 8 electrons. Yeah, has a total of 8. So you're going to have 6 on the outer shell, and of course you're going to have 2 on the first shell, but you're going to need 2 more on this second shell here. So another oxygen is going to come in, creating the oxygen gas. They're going to share these 2 electrons, making it 8, and of course when they share, it's going to become a double covalent bond. All right, so we're going to look at some properties of water. Okay, I'm going to stop this one right here, and then I'm going to talk about the properties of water. Let me just talk about this one particular bond here. In your textbook, now, how are water molecules held together? They're held together by hydrogen bonds. That's how water molecules are held together. I don't see this in your textbook. I thought it maybe the hydrogen bond. Hydrogen bond is in your textbook. section 2.2, page 29. Okay, but I don't see this figure. But anyway, here you have hydrogen bonds here. You have this is a water molecule, which is H2O. You have 1, 2, 3, 4, 5 water molecules, and of course, what's holding them together? A hydrogen bond. Okay, that's important. Water molecules. Water is considered a polar molecule because it has unequal sharing of electrons here. So I'm going to end it here, and then I'm going to talk about properties of water.